talks about Bale grazing and talks about some of the research and demonstration projects that are being worked on. So what we have learned about Bale grazing. Greg, I'll turn it over to you.
Thank you. So I was asked basically to present kind of preliminary results on a 5-state project that we are leading here in Kentucky. So I'm going to do that, but just to kind of give you a heads up, they are very preliminary, especially on the soil testing side. So I will present kind of what we have, but that said, I'm going to supplement it with some other studies out there, and I'll try to give a lot of context in terms of what we're seeing and more importantly, why I think we're seeing what we are. Asked lots of questions. I cut my slides down because I was probably a little bit long, and plus it looks like we have a little bit more time for questions and so forth. All right, so we should have plenty of time. So if you have questions, even while we're going along, stop and ask, and I'd be glad to do that. Where is the slide advancer? All right. Oh, there we go. All right, so I thought I'd just start very quickly giving you a little bit of context because there's multiple states involved, maybe why we're working with the ones we are, some key people that kind of led me to where I'm at right now. So you look at that map, obviously we're looking at the green colored states, and most of them kind of make sense, and you wonder why did we choose that state way up there in the north, New York. And so I'll kind of explain that. So Brett Shedsoy is leading the New York side, and I am from upstate New York, but I did not know Brett when I was there. I didn't know Brett until I think probably 4 or 5 years once I came down here to Kentucky. He knew I was doing work at the University of Kentucky, and when I was up there, and I can't remember if it was at Thanksgiving time or at Christmas time, but one of the times I was up there for a week or so, he had me do like a Tri-County presentation, and then we kept in touch, and he had me out to his farm that next summer. And so this is a picture I took that shot that next summer when I was there. And a little more context, that part of New York was a huge dairy, and I mean it was mostly dairy farms, diversified dairy farms. But we're in the northern end of the Allegheny Plateau, so not the best soils, typically smaller farms. I mean, for New York size. But a lot of them went, they didn't go bankrupt, but a lot of them just kind of went out of business in the late 70s and the 80s just because of government buyouts and so forth. And so a lot of that region, up until recently, was just kind of underutilized land in terms of when I was growing up, remembering a lot of abandoned, on our farm, we had a lot of areas that were just kind of abandoned. The rest of it we just hated, and we hated it to death. And I can remember when I was young, that second cutting would always be beautiful clover. The crows would come in, pick out the bugs, and we'd go out there hunting for them. And anyways, but just very slowly, and it's something you don't see year to year, but you have to reflect back on it. But, those yields kept going down and down, because we never put anything back. We just, had plenty of fertility built up from the dairy side for decades, if not 100 years, then just slowly went. And anyways, Brett's farm was exactly the same. His grandfather got out of the business about the time my grandfather got out of the business, and they did the same thing. It was hayed for years. But he came back earlier, and he was probably about 10 years ahead of me in terms of bringing my family farm kind of back to life in New York. But this is where I came. So again, giving you the context, I'm out at the farm that summer. I had just worked with a good friend of mine. We just fenced in a big portion of my family's farm. Obviously, I'm not doing the work up there. My friend was doing it. But when Brett's cattle are just moving off this section of pasture that you're looking at right there. And I was only half joking with Brett in terms of, Brett, can I bring our cattle and our sheep over here to clean up what you are leaving? Because what he's leaving was far better than what our cattle and sheep were going on to. And so anyways, I'm telling you this because this is why bale grazing is what brought this farm back to life. Brett assured me that his farm was just as poor shape as ours was at that time, that year that he saw it, because we were at our farm here a few days before that. So I hope that gives you some context. And the next two are two pictures he sent to me. So the very early stages of bringing his farm back to life, that's kind of what it looked like. We have a fair amount of snow in upstate New York. And if you look at this picture, this again was the first few years that he was bale grazing the farm. And I don't have to kind of put red circles like I'll do in some of my other pictures. You can see where exactly the bales were set there. The reason being the fertility is really low at that time. And those are in those situations, you will see that response a whole lot more than if I show you pictures of his farm today or the last few years, which I will do later on. So that's kind of giving the context. I was amazed by what bale grazing was able to do. Just fertility-wise, the other huge benefit, obviously, is once you've learned how to do it well, you can easily reduce your equipment hours and your labor by 70-80% in the wintertime, if not 90%. So that was New York. I got West Virginia involved. Ed Rayburn was the forage extension specialist at West Virginia for, I think, a few decades. I found out later on, I think Brett started bale grazing in the early 2000s. Ed Rayburn started bale grazing in the 1980s. And so he's still doing it, so he's been doing it for 40 plus years. To the point where he's built up his base pasture so much, all he bale grazes now is on his hay ground, because that's the only place that he has to think about returning, kind of cycling those nutrients. So Ed got involved. He actually retired. We're hiring him back as an independent contractor this year. And this is the old, where's Chris? That's right, we loaded the old, I thought we deleted off, but is there any way we can load the new one?
Yeah, if you've got the new one, or is it still attached?
So hopefully it, yeah, I'm sorry, I updated a few slides, but it looks like it didn't. No. If you can, say it again. Maybe.
So if you haven't noticed, because of
I can work with this one.
earlier, we're having to do the TV separate than the main screen.
That's right, I can work with this one. I'll just, there are a bunch of deleted and I'll run through them, so that's all right. Yeah. So yeah, I updated the slides. So I'll go with this picture here. So this was a group picture that we took here just, in mid-September. And the West Virginia folks were not in that salon. So on the left is Alan Franzlubers, and on the right is Matt Poor. They're from North Carolina. So Alan is leading the soil side of the project. Matt is a animal science extension. They're beef cattle specialist, and so they're kind of key drivers there. This is the other key members of the Kentucky team. So Ray Smith is on the right. As you know, behind him is Jeff Lemcooler. He's essentially my co-PI on the project. And then Tom Yankee on the left, he's a retired ag agent from Anderson County. Basically, he has the hardest job of all. He has to try to keep a bunch of academics grounded in reality. So, and he's done a very good job with that. That's the Virginia folks. And then, and boy, it's been like 10 years since the other picture that I showed of Brett. But Brett's there in the middle. And then John Burns is on the left. And I'll show you a couple pictures from his farm. There's two basic types of farms, and again, I'm just giving you context, and we'll look at the results. So the main farms that we're actually collecting data from are what we call core farms. So those farms, they basically have a 3-year commitment once they start bale grazing, and what they do is they bale graze the first winter. I'll show you kind of the layout of one, but they'll bale graze, and then we'll essentially take forage measurements and soil test measurements for 3 years after that. And I'll show you a map here in a second of those. Demonstration farms are ones that we're going to bring on this winter and next winter, and really we're not collecting any data unless the farmers and county agents want to, and we can work with them on that. But the main goal there is to get a bunch of these farms all through the state, so that, because what I've learned is I can give all sorts of PowerPoint presentations, which I do all through the state, but most farmers are not going to kind of pull the trigger on bale grazing until they actually see it done on an actual farm, and that usually means it's got to be pretty close to them. So that's kind of the main goal of those demonstration farms, just to spread those out so we can have a place people can actually see bale grazing in action. And the core farms also serve that purpose also, but they have a whole lot more commitment than just what the demo farms are doing. Here's a map of the core farms. And you can see most of them are kind of concentrated just west of Lexington. And that's mainly because we're collecting a lot of data, so we can't really afford to jump around, to all areas. And the ones kind of in the outskirts, they're actually collecting a fair amount of the data themselves with the county agents, and that's kind of how we've done that. Oh, well, let me back up one. So one important distinction here is because all the data on the core farms that we're collecting are on actual farms, we're not having replicates within a particular farm. In other words, if we did this on the University Research Center, we would do it on one location, but we'd have multiple plots on that same location. Those would be the replicates. So from a statistical standpoint, we could see how things are changing. We can't, from a practical standpoint, do that on actual farms because it'd just be too much work for them to have multiple places. And so we don't have replicates on the farms, but we have so many farms that the farms themselves become the replicates. And this is kind of an area that Alan Franzlubers, who's leading the soil side, really specializes. He pretty much all his research is done kind of using this technique. So from a pure standpoint, statistically, we can't say on a farm that our high density bale grazing treatment is producing more forage than the control. We can, from an unofficial standpoint, if it's double, we can kind of tell that. But from a statistical standpoint, we can't really say that. But what we can do is all these farms collectively, we can see how things are differing. I'm going to show you a few pictures of just some of these core farms here, and then we'll look at how the treatments are set up. So here's one in the southern part of the state, Monroe County, the Peden Farm. I think they probably are our largest farm that we've worked with so far on the core. They've got about 85 cows in this herd. If you look there, I think there are 8 bales set up that they're going to go through. And that's actually, this is not part of the treatments. They finished probably 2 weeks ago on the other side of that fence with the treatment pastures, and now they're just bale grazing for fun because they liked it so much. Here's one in West Virginia. This is interesting because Richard Law, the first time I talked to him was actually at the Appalachian Grazing Conference when I presented on bale grazing, and this guy at the very end of it stands up and says, Greg or Dr. Halich, whatever he said, this might work on your gently sloping ground in central Kentucky, but it will never work here in West Virginia. That was 2 years before he sent me this picture and asked me if I could come out sometime when I'm out in that area. And he's bale grazing on slopes. That picture does not do that justice. It's so steep there that you could not have paid me enough to bush hog a pasture on that slope. So and what I like about Richard, and I say this at every presentation I do, I start off saying, listen, I want you to be skeptical because I'm here, you don't know who I am, you don't know me, I can be, and if you're a farmer, you need to be skeptical because someone is always trying to sell you something. So I said, be skeptical, but have an open mind. And Richard had both, right? He was skeptical, had that open mind to try it. So this is not one of the treatments, and I'll show you some of that. So, but point being is he learned to do it on steep ground, and if anyone says it can't be done, I'll send them to Lost Creek, West Virginia. This is a grazing dairy in New York. They are using baleage, which does work for bale grazing. I prefer dry hay, but it can be done as you see here. And I skipped a bunch of these, so we'll just. Yeah, I don't know what happened because that's okay. We'll go through it, and I think I added one that obviously I can't add in there. That's fine. No, don't. We'll get by. Just realize that I'm going to skip through. Go ahead. I don't want to get bogged down, but basically, I will show you here in a second in terms of tonnage. I don't care about the distances. I care about how many tons of hay do you have per the acre, and it will depend on how big your bales are. If I had to guess here, I don't remember the size. I don't remember if he used 5x5s or 4x5s, but let's ignore that question for a second. So all our farms that are core farms have, they will look differently. Some may have been 30 acres, some may have been 15 or 10 or something, but all of them will have the same basic treatments involved. They will essentially feed half their hay at a low density, which we're saying is 2 tons to the acre. So if you're using 4x5 bales, that 2 tons is going to be roughly 5 4x5 bales to the acre. 5x5s, I usually figure around 1,000 pounds, so that would be 4 5x5 bales to the acre. Acre's about 69 yards by 69 yards. So it will depend on the distances, and I usually go by yards, and I don't remember feet. And then they will have a high density, which I really should call something different than high density. It's just a relative term. But my high density at 4 tons an acre is a low density if you go up to Saskatchewan or North Dakota or somewhere like that, which we'll talk about keeping that in context. But really I should call that medium density, and that's just double the number of bales per acre. Keep in mind, though, that that is a lot lower. You can see how many bales, and you can kind of see the cattle in there just as a reference. It's still pretty low density compared to how a lot of people are going to feed, particularly as you move north of here. Which, by the way, in Kentucky, I really had to play around with this for 2 or 3 years before I really found a system here in Kentucky that worked well compared to where I saw it in New York. Main thing is we have to feed at a lot lower densities here, or you will tear up your pastures when it gets wet. And sometimes you want to tear them up, and we can talk about that in the questions later on. And then we obviously have a control somewhere there. That would be the first winter. Second winter, we basically break up the low density into two. On half that low density, we will feed a second winter at the low density. So essentially, we have 3 treatments: a high density, low density, then a low density that's been fed twice that also has 4 tons, but fed over 2 years versus 1 year. Does that make sense? All right. So let's talk about soil sampling. Again, Alan Franz-Lubers runs this part of the program, but all the states participate. Obviously, we're doing the work. So I like to joke around with Alan. He has a heavy predominance of German blood, which when we're in Indiana we got to see that at the German bar. We had a good time. But Alan is, I would say, particular. Would that be an accurate description? And so we all have the same standardized equipment. Even we've got to have the same little white bucket. And yes, he has a detailed diagram about how to cut the hole at the bottom, how to insert the flange properly. And so I can say this because those that you know me, I have a little bit of this blood myself. I'm not as bad as Alan, but I can be a little particular myself for those that you know me. Chris, I don't think you know me well enough to laugh. Kidding. So soil sampling, we break up into fall and spring sampling, and we originally called it fall sampling. It's really fall-winter because if farms don't commit to doing this until January, we're obviously not taking that first sample until January. But we take a sample before they start bale grazing, which would be year 0, and then we take one that next fall, and then we skip a year just because we have so much sampling by what would be that second full year because we have all the farms coming on. That Alan said, let's just skip that second year, and we'll get the long-term changes that third year. So that's what we're doing. That's one reason, especially on the soil side for the fall, we don't have a lot of good data because we skipped that second year. Spring sampling is just done one time after the bale grazing, and it's distance dependent. I'll show you that right after this to show you how that's done. Everything is to a 4-inch depth. So this is a spring sampling. You can see that step-in post is roughly in the middle of where the bale was fed, what I call the impact area. You can see a bucket there. If you saw on the computer, you could see it better, but there's a drill sticking down. I can't even see that hardly from here, but it would. Anyways, he is taking the 8-foot distance, and he's got his drill auger, and he'll go around that every 90 degrees basically to pull a sample. And then he'll go to the 16-foot distance, do the same thing, then 32-foot, and he'll do that on a number of bales until he gets the required number of cores. So that's how we do the spring sampling. The only reason I think we kind of knew the results, what they would be in the spring. Basically, we knew that the bulk of the nutrients would be where? The 8, 16, or 32 feet. In the 8, right, in that impact zone. So we kind of knew that. Just the question was to what extent, would that change? So again, I'm going to be showing you some preliminary results. I will just state right now, a lot of these are going to be kind of boring because it's just kind of like we thought. So I'm going to go through the spring fairly quickly because it's going to be about like we thought. And again, I will try to give context to that. So here's phosphorus, and then that would be the 8-foot distance. I wouldn't pay attention to the exact numbers, just kind of look at trends on here. So obviously, like we thought, the highest concentrations would be at that 8-foot distance. There's a 16, it's going down, and it goes down a little bit between 16 and 32, but not a whole lot. Here's potassium. Starts out, fairly high. In this case, it drops a whole lot quicker, which is kind of what we thought. We can talk about that here in a little bit, why. And it basically is plateauing from that point a little bit lower at 32. Calcium, for whatever reason, didn't change a whole lot, maybe because the original concentrations are so much higher relative to the other nutrients. I don't know. And I'm going to skip through some of this. These are things I had taken out. All right, fall sampling. Again, we skipped year 2, so we really don't, and we only had a few farms start in year. So year 1, we only had a few farms that started. Basically, every state was supposed to have 2, but most of the states only end up having 1. We had 2 in Kentucky. But we did that for a purpose because we knew that we're going to screw up that first year, so we figured let's just have a few farms that we screwed up on and learn from. I mean, I say that somewhat jokingly, but that's what happened. So it's a good thing we didn't have too many. But basically, most of our farms came on in the second winter and then the third winter. So what I'm saying is we don't even have complete data from the farms that started the first year. Yeah, we will have when we're done fall sampling and when we get it analyzed. But point being, we really, especially on the fall sampling side, have very limited data. So basically, Alan didn't even try. I mean, I think he did, but he said we don't have enough data that we can really show anything for that. So we do have some better data on the forage side. I think, again, it's preliminary. It's based on relatively small amounts of data compared to what we'll have when we're done, but it does look interesting. So we'll spend a little bit more time on that. So we measure more than just these 2 things, but the 2 things we'll look at here are the most interesting, and what I think what we originally thought that we'd concentrate on anyway. So 2 things we're going to look at are forage mass, so basically forage production, and then botanical composition. So forage production, obviously, to see are we getting an increase or decrease in production on areas that we bale graze versus control. And then botanical composition, I think mainly because one big concern a lot of farmers have that are considering bale grazing is they're worried that they're going to have a weed infestation that first year, and that may continue, right? Because you will pug that ground. Even if it's perfect conditions, I promise you that first year, from my experience, you'll have more weeds, hopefully not a whole lot, and hopefully long run with increase in fertility, it will actually be improved versus the control area. But we wanted to look at that statistically in detail, so that's essentially what we're going to kind of do here with the botanical composition in terms of showing you that part of it. We are sampling for 3 consecutive years after the bale grazing with the botanical or with both these, and we do it twice a year, spring and then late summer, fall. Basically, the reason we do it in early spring is because everything is reset, right? Wintertime, everything is down to 0. So everything that grows in the spring before we graze it the first time, we can directly compare that, right, to each other. So basically, we need to do our first sampling before they graze it that first cycle through. So it does involve, and this is one reason the demo farms are so much easier than the core farms, is because there's a lot of coordination here. We've got to get on the phone with the farmers to make sure that, right, like so by the way, raise your hand, we have one core farm here today, Ben Smith. So he's in north of Hardin County, remind me? Meade County, I'm sorry. When you present, you kind of are focused on the things that you're in. Anyways, so I'm sorry, I should know that. But, we have to coordinate to make sure we get out there and it doesn't get grazed before. And so there's a fair amount of coordination, but so far that's worked very well. And then the next time we sample will be in any time from late summer through late fall. So we have a wide window here, but basically what we need to do is we have to have the farmer clip the pastures all at a uniform rate at some point in the summer. And why would we want them to do that? I want you to think about this. Why is it important that they clip those pastures if we're going to sample a second time? So let's just say, hypothetically, let's say the control was growing more grass than the other areas. It already may have a whole lot more build up, and if we're measuring it late in the fall, a lot of that may have grown in the spring, right, and not in the fall. So in other words, we're essentially trying to reset everything at a point in time so that we're going to measure it before they graze it that next time so we can directly does that make sense while we're doing that? And that's what we're doing. Again, that takes some coordination to make sure it gets clipped, and then again to make sure that we get out there to do the forage sampling before they graze again. And so far, I think we've not had that problem. At least no one has told me that, right? All right, so let's look at some of the results from this. So let's first look at the forage growth of the forage mass sampling. And here, this is year 1 that we're going to look at. We'll look at years 2 and 3. We'll start off with year 1. So I'm first going to combine again, we did the sampling both in the spring and then late summer, fall. So we did it 2 points time, but I'm going to start and combine the 2 together, and I'll tell you why here in a second, just to show you sometimes averages can be deceiving. So if we combine them, and I'll go through each one of the next few slides will look the same, so I'll walk you through it. The one on the left will be the control. The next one over will be the high density. The third one will be the low density that was done 1 year. And then the final one on the right will be the low density. It was bale grazed twice, 2 consecutive winters. All right, so what I'm going to do is on each of the next few slides, I'm going to basically set that dashed line at the top of the control. Does that make sense? In other words, we'll compare everything to the control. So if we combine spring and fall, looks like the high density had a little bit better growth, and then the low density both had a little bit lower growth, right? Not a whole lot of interest there, other than it looks like, one of the things people were afraid of is that the yield would go down substantially in year 1 with bale grazing because we've had all that impact. So I guess number 1, did it go down substantially? No, it's about the same, but here's where it's interesting. So if I show you just the spring and then just the fall, the results change quite a bit. So if we look at just the spring, what actually happened there? Yields did go down, right? Which is what I could have told. I couldn't have told the exact number, but by the 3rd year that I've been and I started bale grazing, I think in 2012, 2011, 2012. Just visually, after a couple years, I could tell you that. Usually, where you bale graze in the spring, you'll have a little drop in production. So it kind of told us what we already knew. But here's interesting. So if I show you the fall, the late summer fall now, what does that story tell us? Production actually what? Increased. And that's exactly what I've seen in the past also. You have a decrease in the early spring. Actually, and we didn't do a sampling in June and July, but typically what I see is by June or July, the production actually goes up. So the story here is, and by the way, is having a little bit of drop in production in spring compensated by increase in production in summer and fall a bad thing? Not in Kentucky, right? So in other words, you wouldn't want to do that on 100% of your acres, but if that's over 25 or even 50% of your acres, that may be a good thing, right? Even in that year number 1. So years 2 and 3, I will combine the two together just because from my experience, after that first year, you don't really see a change between spring and fall between the control. Would you agree with that, Ben? Yeah. So after that, first year, you will see that dynamic. After that, it's just, you won't see the seasonal aspects like you do that first year. So here's year 2. Again, keep in mind, we're progressively getting less and less data. Year 1, we have a lot of data. Year 2, we have a lot less. Year 3, we have just a few farms on it. So if we look at year 2 data, high density, increased production a little bit, low density decreased a slight amount. Overall was probably just a slight gain in production. My experience is it's usually a little bit better than that, but again, this is, we can talk about some of this later. And here's year 3. This is more what I typically see, kind of a bump somewhat in that realm. That said, we only have a few farms that went into this year. And this is just Kentucky data that we're looking at right here. We didn't have the rest of the states combined at this point. So let me stop here for a second before we go into botanical composition. So any questions on the forage production side? Chris? Yes. Good, very good question, because the answer is it depended on the farm. Initially, so there were things that I wanted to do as the lead on this project, and then I had to work with 5 other states, and what I wanted to do sometimes, guess what? Got overruled by the other, and also I learned I had to be very flexible, which Chris knows is not a good, strong suit of mine. But I have learned through this project. Damn it, Greg has learned something the hard way here. So I wanted to no reseeding, probably exactly why you're asking the question, right? I'm guessing. So from a statistical standpoint, I didn't want to seed anything because I wanted to know if we almost would have to do it. Everyone seeds or everyone doesn't seed, in my opinion. So we did allow it, but all I will say is probably 1 farm out of 5 probably extra seed. And what they could not do is they could not seed anything other than that impact zone where the hay was and where you had the disturbance. So even at 4 tons the acre, it was less than 1% of the overall area. So keep that in mind. In other words, statistically, we're not going to see that. But that said, I would have preferred that we had no seeding, but again, we had to be Ben, did you seed? So you were one of the 5 farms that did that. Yes?
One of the things you'd be testing is the seeding that's coming from the hay, and wouldn't that depend on the hay that you're getting?
Yeah, and there's no way we're going to control that, so we didn't try to.
Okay.
Yeah.
It just seems like a very big variable to me.
We'll have the botanical composition.
We will look at that here in a second. But it's not controlled by hay quality or anything like that. It's just all lumped together. My experience, you've got, I usually get pretty good quality hay, so that's like, I'm not part of the study, but I don't see a whole lot of natural seeding like in my bale grazed areas, but if you have hay cut in July, I promise you'll have a lot of natural reseeding there. So yeah, let's wait till we get to botanical composition for some of that, and that may show you what's going on. Other questions here? All right, let's go to botanical composition. And I'll do the same thing. I'm just going to kind of walk you through before we look at the results here. So this is year 1, but basically same thing. We're going to first, this is where I wish, this is one thing I actually changed so what I changed, again, I don't know how we screw up here, but I just want to make sure you realize first bar is control, second one's high density, low density 1 year, low density 2 years. And it didn't get changed. That's right. I screwed it up. So where the arrow is, so this botanical composition, if you go from the bottom of that left-hand bar up to that, where that arrow is, that is the percent of that, on average, all the farms lumped together, that is desirable grasses. And then if we go up to that next arrow, that difference there, that would be the legumes. So it looks like, 17, 18% of the pasture on average was legumes. Everything above that, even though I know there's some people in here that like weeds and like their cattle grazing weeds, is what we characterize as undesirable. So let's not argue about that. Because again, the main reason we did this is to see if we had weed encroachment on these areas. So using that gray, so where that arrow is right now, I call that kind of light or medium gray. We will use that. We'll draw a line across it and compare it to the other ones. Is that you all understand what we're doing? So, in other words, the difference between that dotted red line and right below that, the medium gray, would be the increase in weed increase in weed predominance, roughly. So, do we get an increase in weeds that first year? Yes. Is it night and day difference? No, it's just a few percent. But that few percent, 90% of that will be where? In that impact zone, the 4 to 10 bales per acre. So visually, it looks a lot worse than it is because you're naturally drawn to where when you go into bale grazed pasture? All those impact zones. And you're looking at those and you do see almost all the weeds, increase in weeds in those areas. So visually, in my opinion, it fools people. They think there's a whole lot more weeds there than there actually is. Is that a fair assessment? Okay. Okay, so let's go to year 2. So that was year 1. Remember, I don't care what you do. Anytime you're out on pastures and it gets wet, if you do stockpiled fescue and it gets wet, I can guarantee you that next year you'll have an increase in weeds. But it's going to be a short-term impact. So keep that in mind. Context. So here's year 2. What's the story in year 2? Slightly fewer weeds on the bale grazed areas. Now, is it statistically? Probably not, but from my standpoint, what would be the reasoning for that? If we have a bunch of pastures that are low in fertility and we put a lot of fertility, what's that generally going to do to your weed population? No, it's going to drop the weed. It's going to increase the desirables, right? So I don't know if that's what's happening, and again, statistically, it's probably not enough difference statistically to say that's what's going on. But the main thing is, did we see an increase in weed production in year 2? Absolutely not, right? Here's year 3, same type of story.
Are you bale grazing the same field for 3 years?
Good question. No. So high density is 1 year. Low density on half it is 1 year. Low density times 2 was low density 2 years in a row. And that's it. No more bale grazing. And we'll get to the context of that because it's important. In other words, we're doing a limited amount of bale grazing at relatively low densities compared to what you're going to see if you just do a random Google search of bale grazing pictures. I guarantee you're going 9 times out of 10 you're going to see a bale from me to you, right? that kind of spacing, which is going to be the 16 tons or better to the acre.
How did you decide upon how many bales to give them access to?
At a given time. No. So the question is, how did we decide how many bales to not to put out in the pasture, but to give them access to? That was complete discretion of the farmer, and mainly how like the Peden farm, they had 85 cows. They could not feed 1 or 2 bales at a time unless they're going to move it multiple times a day, right? So number one, it's function of how many cows they have. Number two, how often do they want to move that fence? So super flexible on that. You could have the same farm, let's say a 40 cow herd, that they might be moving that, they might have access to 8 bales at a time, or they might give them that will last a week, or they give them 2 that last a day, that type of thing. Completely up to them. I don't really think it's going to impact anything that we're seeing here, because the cattle are still going to be on an individual bale on average same amount of time. Where were we? Okay, other questions? Another very good question. So this is another example of where I had my idea and then I had to compromise. What do you think my idea was? You know it. Yeah, my idea was everyone needs to use bale rings. And what did a bunch of other people want to do? Let them do whatever the hell they want, and that's what we did. So this is about where I gave up. I said, do whatever the hell you want. Yeah, these are painful questions to have to think about a second time. All right, and I'm completely distracted now, so I'm trying to regain my focus. All right, so I said I would try to give you context, right? So this is an example of trying to give you context. This is actually one of my farms. It's Greg. So Greg Brand, you and Debbie were on this farm the first year I bale grazed. This is the second year, so where I'm living right now. Do you all see a lot of broom sedge there? And Greg, I would say half the farm looked like that. Not all, but roughly half. This is the second winter, though. What do you see in that circle? What do you think happened there? A bale. Not that year, the year before. This is the second year I fed. So the point I'm trying to get to is the response. 2 things. One, the response in terms of forage production that we're expecting will depend on our initial fertility, right? So even though I didn't forage test this, I guarantee the response that I would have on this farm would be a whole lot better than if we tried doing this on Greg Brand's farm after he's had great grazing practices for decades, right? The other thing is, on this farm, I can almost guarantee that I had a decrease in weed production the first year compared to the average, because it was all weeds to start with, right? So in other words, it matters in terms of the context of where you start. Again, more context. So this is a farm in upstate New York. Jeff Bale, he's become a good friend of mine. He's only about 15 minutes from where I'm from in New York, and again, didn't know him until we did this study. So Jeff really took to bale grazing. In fact, he is so enthusiastic about it. He not only did the 3 treatments that he was supposed to, the 2 tons, and this again, I changed it. I took the 16 tons. So he did the 2 tons and then the 4 tons and the 8 tons, the 2 by 2 and the 4 on the left. He did 16 tons that was not officially part of the project on the right. But Ray, I don't need to put a pressure plate meter on this to measure forage mass. You can statistically say which one has more forage mass here. The 16 tons to the acre, right? But the point being is, remember, we're bale grazing at relatively low densities compared to what you might see in other places. So we can't expect miraculous results in terms of forage production by doing just 1 year at 4 tons or 2 years at 2 tons. You really have to. And unfortunately, and I'm sorry, I should have said that NRCS is sponsoring this project. They're paying for it, and they're more than gracious about it. And they've worked with us. But it's still a 5-year project that we're only collecting data for 3 years, folks. That is a short-term study for something like bale grazing that you really need a decade or longer. Victor, would you agree on that? That to see really how is it going to change that pasture or hay ground? So that said, keep that in mind. We're bale grazing at relative low densities, but I'll again kind of give you context. This is that same farm in West Virginia I told you about, Richard Law, and it just turns out he's not far. When I go back to New York, he's off the interstate like 20 minutes, so I usually stop and see him in the summertime. So this was late July this year. He started last winter. And so what I want you to look at, he's looking at an impact zone from last winter. And no, that isn't a different grass species there. That's all over there. It's just, why does it look like a different grass species? Because of the fertility. And I'll give you more context here. So you saw most of Richard's farm is like this. He has a couple benches halfway up the mountain like this. They're not flat, but they're relatively flat compared to the rest of it. So historically, they're in the very bottoms, which are narrow, is where they'd hay every year. So this has probably been hayed for 100+ years. And guess what? It's so steep, I'm sure they've not put much commercial fertilizer on it, because we barely got up there with a 4x4. The UTV. So my guess is, I haven't looked at the soil samples here, but probably it's low in fertility. And so you see a tremendous what? Increase in forage production in that type of situation. I'll show you another picture, and this one should stand out also. You can see very clearly where the bales were there. By the way, there's no bare ground there. It filled in nicely. In fact, the forage production was so high as the grass are starting to lodge there. So that's mostly foxtail you see here. And at first we thought just foxtail infested the areas where they bale graze. Then we started looking, there's a little foxtail all through that pasture. It's just the fertility was not there for it to express itself. All right, so I'm going to give you results from one other study, and then one I deleted, but it's still on there, so I've got to fly through. So this is one that this Paul Youngnich did a study in, I think, 2008. And I've talked to him on the phone twice, by email multiple times, just to get more details, because he did, I thought, such an incredible job in terms of details of setting this up. But what he did is, this is in Saskatchewan, and we'll give context for that versus Kentucky. But basically, they took half the cow herd at the university, they bale grazed it on 5 acres, they took the other half, they dry lotted, quote, dry lotted. Now in Saskatchewan, what he told me is, he said that ground was frozen for 6 months solid. And so he said, effectively, he said it's like a feeding pad. And then they scraped up all the manure and then spread that over 5 acres adjacent to where it was bale grazed to see how that compared to bale grazed, and then they hit a 5-acre control. And so that's what we're going to look at. But what I want to focus on here, it ended up over 16 tons the acres what they bale grazed, 16.8 tons. So very quickly, I'll go through a few of the soil tests. So here is inorganic nitrogen. So you can see the dry lot essentially had no increase in inorganic nitrogen. Bale grazing, it tripled that level. Here is potassium. So basically no increase from the 5 acres that was spread with manure from the dry lot, but a 64% increase with the bale grazing. Yeah.
About the dry lot, are they testing, were they dry lot on 5 acres, or they collected the manure off the dry lot?
No, I forget, small dry lot, but then they collected all that manure. And I talked to Paul. He said, no, we didn't get 100% of the manure, but he said we spent a lot of time he said if I had to guess, we got easily 95% of the manure. And then they spread that on 5 acres, just like same number of cattle. So in other words, 95% of the manure was spread on 5 adjacent acres to compare the two. Does that make sense? And Ricardo and I talked about this. Those potassium levels are sky high to begin with. It must be that area. So, but anyways, we're not going to worry about that. But they were already high to begin with. Here's phosphorus. So the dry lot did have an increase compared to the control. And we can talk about that here in a minute, why we saw that, but nothing with the inorganic nitrogen and the potassium. But bale grazing still did a little bit better on the phosphorus. Now, in the end, this is what it's nice to know what the soil tests are, but in the end, do our animals eat the soil tests? No. We want to know what the forage production is, right? So that was what I was most interested in. This is over 1.5 years, so 2 cuttings the first year and then 1 cutting in early summer the second year. And so we have, again, controlled dry lot and the bale grazing. So I'll just note a reference. That is in pounds per, of course, he had it in kilograms per hectare or whatever. I converted everything over. And that would be for more than a year and a half, which is ridiculously low here in Kentucky. But this is Saskatchewan, where apparently they get 12-inch rain on average a year. So I've got to assume that's kind of average. I don't know that for sure. But very low number compared to Kentucky. Here's the 5 acres that they spread the manure from. So they did have a big jump with the manure from the dry lot, but it looks very small when I compare it to what? the bale grazed area. In fact, it looks ridiculously low. So my question is, again, he didn't get 100% of the manure, but he said pretty close. Why are those two numbers not equal? Why did they not get as much forage production in the 5 acres that they spread the manure versus where the animals directly fed themselves on those bales with the bale grazing?
Urine and trampling actions?
So I've heard urine, and trampling. So we don't know for sure. Statistically, we can't say. Again, I've talked to Paul. Paul and I both think the same thing. It's mostly the urine. He said the one thing that you're not collecting is what? Urine. Now, the trampling, maybe, but again, this in Kentucky, maybe, but again, this is Saskatchewan where those soils are frozen for 5 feet down. So I don't know how much trampling, that effect you're going to have there versus Kentucky. But my guess is a big chunk of it is urine, potentially some biological activity just from manure, sitting in one place versus, I don't know, but they were scraping up the hay. They try to scoop up everything. So I don't know, Greg. But the main thing is, for sure, we're not getting any urine. By the way, in a feeding pad, how much urine are you going to scrape off a feeding pad? By the way, I've been saying this for like 8 years now, but I've said the first person to do this gets a $100 bill. Dump out 40 or 50 gallons on a feeding pad, wait 2 minutes, and when you front unloader, see how much of that you can scoop up. If you get more than 5 gallons, you've got the $100.
Better be careful in Saskatchewan, Greg, they'll scoop up the ice.
The urine freezes. Yeah, they might get me on a technicality. And I am skipping through this. This part I took out just because it's interesting, but not that interesting. I found out it was confusing also, so we're going to skip through it. All right, so let's, again, giving context. So again, we talked about feeding at low densities for 1 or 2 years. We should not expect to see drastic results compared to Paul Youngnick's, where he fed a little bit over 16 tons the acre. It's going to take us, even at the high density, 4 years of doing that, right, to equal that. And at 2 tons, it's going to take us 8 years to get to that. But the reason that we didn't, in fact, there were some people that wanted to feed, I think, if I remember correctly, 8 tons an acre. Ed Rayburn wanted to. And I vetoed that. And I said, Ed, the primary reason we're doing this, yeah, the data is important. We want to collect data. But the primary objective of this, and this is what NRCS said when we got their notes and stuff, is we want to provide demonstrations to farmers so that they're not scared from trying something like this. So what if we did 8 tons the acre in Kentucky, and they started bale grazing when we got that, just before we got that, one of those 4-inch rain events last year, and they were on that for 2 or 3 weeks, and that whole pastures. What are the farmers in the area going to think about that? They're going to say what? Exactly like we thought, right? Bale grazing is not going to work. They went, well, good. So anyways, keep that. One of the reasons we're feeding at low densities is because you've got to be very careful down here in Kentucky or Tennessee or Missouri or wherever, our region, because of how wet we are. So we're in it for more of the long haul, right? In fact, when I bale graze, there are a lot of pastures that I've bale grazed consistently every winter for 10 to 12 years. In fact, we'll look at one of the ones right here in terms of what that long-term changes is. In fact, we'll look at it right now. So this is the first farm that I've been bale grazing. I think I started in 2012. I do have a soil sample somewhere from 2010 or 11. I bought the farm in 2009. It was a hard copy. I cannot find it. I'm not trying to hide it, but I know roughly what things were, but I cannot find it. I did not test organic matter. I didn't even know you could do it because you have to pay $6 extra. So I couldn't even tell you what organic matter would be anyways. I didn't have it tested. But it was tested. I tested it in 2017. Alan Franzlubers did the test in 2023. He was passing through and he was doing a multi-state project. So he did that sample. So if he screwed up, you can take that with Alan. But I can tell you, Alan doesn't screw up very often. So I will just say that. So here's where the soil tests were in 2017, and I'll throw it at you again, Ricardo. Could you work with those numbers in terms of good forage production in Kentucky? So they're pretty decent to begin with. In fact, just organic matter-wise, how would that compare against most average farms in Kentucky? Very high to start with. But again, I've been bale grazing for about 5 years or so at that point, which we don't know our start. So that was 2017. 7 years later, that's where I'm at. Ask the question again, can we work with this? Now, I will be the first to say, not all that is due to bale grazing. I mean, I don't move, Greg Brand knows, I'm not ridiculous rotational grazing. I try to do a good job, but I'm not like a superstar that I'll show you another farm that does. But there's no doubt that with good basic rotational grazing, and I would say this is just my pure gut feeling on this, the biggest thing is I am careful to never overgraze a pasture, including a drought. In fact, I've been bale grazing at low density since early August to make sure that I don't have a pasture on my farm that's overgrazed. So all I'm saying is part of this is due to bale grazing, part of it's just due to other good practices. I can't tell you what's what, but I can tell you bale grazing is an important part of that, and it's what I call it's priming the pump. It's the easiest way I know to get the biological cycle going on a worn-out farm. And then once you do that with good rotational grazing, making sure you don't overgraze, you can kind of continue doing it. And then here's the other pasture, which is adjacent to it. Again, almost very similar numbers. So that's the long-term perspective. In other words, I've been, at that point, 2023, I've been bale grazing for 11 or 12 years. We're not going to have immediate results, but long run, again, it's not all due to bale grazing, but I would credit a good chunk of what you see to bale grazing. Greg?
Normally it takes 10 years to add 1% organic matter, so that's sped it up a good bit.
Okay, visually, here, this was 2016, decent pasture. Here's 2023 in early July. No, it didn't look like anything like that this year, the drought, but if I can get that kind of production on a good year, which early 2023 was, I will be very happy. Let's just skip through this. This isn't as important, and that way you'll have time for, let me show you these pictures. All right, so this is Brad Chedsoy's farm, like it was either 1 or 2 years ago. So again, I showed you a picture in I think it was 2010 or 2011. This is what his farm looks like now. Does that look pretty good? This is John Burns. He's one of the other ones. And I was there in this last year in late July. Now, John Burns hasn't been bale grazing as long as Brett, but he probably about as long as I have. And he doesn't just bale graze, he enrolls because he has sheep also. In fact, you can't see them all in this picture, but in the very back, you can see the flurd there, the cattle and the sheep in the very, very background. So, and again, he's been doing it for about 12 years. That was cut for hay about 5 weeks before I took that picture. But this is just his permanent pasture, and it all looked like this. And I'm telling you, you'd have to get down on your hands and knees to even find a weed in that pasture. I mean, it was ridiculous. I mean, I'm not easily impressed, and I told John, I said, when we're done, I said, this may have been the best grazing farm I've seen in the last 3 or 4 years, other than Greg Brand's, of course.
I wonder if he sprayed it.
He what?
Sprayed, used herbicides in the past.
No, he is not, no. Trust me, John he does not, no, there's no spraying whatsoever on that farm. What I want to point out, though, is those 2 farms are in upstate New York. So roughly where that arrow is, that's about, they're on both sides of it a little bit. This is where we're at roughly now in Kentucky. If I go north-south between those 2 lines, that's about 325 miles. They're both grazing full-time in the spring between April 10th and April 15th. And that is not pushing the cattle. They're getting 4 to 6 inches growth before they put those cattle out here. When on average our cattle farms here in Kentucky grazing full-time? About that time. Would you agree, Ben, on that? Yeah. In other words, they're 325 miles north. They're greening up at the same time the average farms are here in Kentucky. And that's one of the, it's not just bale grazing, but it's just getting that organic matter going, getting the biology going. It's amazing. And it's not just in the spring, it's the fall also. I get more growth in November on that first farm that I've been doing this for that long. I get more growth in November now in the same climatic conditions that I used to get in October. It's that drastic in terms of the changes. Last thing I wanted to, this is kind of out of the box. I just want to get people thinking about this because all our other speakers have talked about shade, at least I did yesterday, and I was working most of the day. So I wanted to talk a little bit about that. I never used to think shade was that big of a deal in terms of fertility drains, but This is the first shade wagon I built. This would have been like 8 years ago. It went to a friend in Greene County, Kentucky. They basically cleared out all the trees. They do row crops also, and when grain price got ridiculously high in the late 2000s and through the early 2010 to 13, they cleared out all the trees here and took it out of cattle, put it into grain, and then when prices crashed, they wanted to put cattle back on there, but they had no shade. So we built the shade wagon, and I learned, I wasn't there every day, but from the few times, I was just amazed by how much fertility just in a day or two of cattle being under that shade wagon, what a difference that made. And then, I took that slide. This is on the second farm I had, the one I'm still rebuilding the fertility on. And so I actually built the shade wagon years ago, but I had it on a rental farm that I lost adjacent to the other farm, and so it just sat there. I took the shade cloth off, but I finally moved it back to where I'm living now 2 years ago. And so I'm living there, so it's easy for me to look at it on a daily basis and even move that on a daily basis. And what I found is just and there's just 15, so they're probably around, when I took the picture, it was in early September, they're probably about 1,050 to 1,100 pounds average. They're all finishing cattle. But with 15 of those animals in just one day, and that's a 32 by 24 shade structure, in one day, they saturate that area. And I've learned this, and they used to be there for like a week. I just didn't realize it was saturated because now that I move it on a daily basis, you can see how it's like whoever's doing the poultry. It's almost like running poultry through there. It's that drastic. That's them being there just one day. The cattle were there that day, and I actually moved it just after I took the picture. I just moved it 20 feet to the right so that they had fresh grass there. But what I'm getting at is, theoretically, we're returning 90% of the nutrients back to pasture, which we probably are. But if you're like on my farms before I started doing this, a lot of those nutrients are going where? Under the trees. We can talk theory all we want, but in terms of effective nutrients, it's nowhere close to 90% going to the pasture where we want it. So I'm not here to say we all need shade structures. There are parts, on that size farm it works. On my rental farm it was a pain in the butt. And on a bigger farm, where you have 100 head, you're going to have 3 or 4 of those wagons hooked together or something. So I'm not saying that is what everyone should do. It's just I think we need to think more about the shade part of it, whether it's we have heat-tolerant cattle like Jim has talked about, or I don't know what I'm just saying it's something to think about. I think it's a bigger problem than we have admitted collectively in terms of draining fertility. Last thing, so we're done with the core. Well, we're still taking measurements on the core farms, but we're done in terms of bringing on the core farms. Now we're looking for demonstration farms, and so we can't have one in every county. We're basically looking like every 3 or 4 counties partnering to have one. So Colby, I think we've got some in Clinton County. Whitney's gone. I think. I'm pretty sure we've got some in here in Grayson County. Adam, I think we're not 100% sure, but we might have. There's a good chance we have some in Hart County, right? So we've got a few, but we're still looking for a lot of areas. So if you're interested in potentially doing this, working with us, let me know. And otherwise, hopefully, I've got a couple minutes for questions here.
Let's give Greg a hand. Any follow-up questions for Greg as we're shifting things over?
Victor. So the question basically is, what are the pros cons of hay rings versus not hay rings? With bale grazing. The biggest trade-off is you will have a lot more hay waste if you don't use rings, and it will almost be exponentially your hay quality. So in other words, if you have really good hay quality, the loss won't be quite as bad versus if you have poor hay quality like we're talking about, right? Now the flip side of that is, if you can buy really cheap hay. I've got a friend, in fact, his wife was, and Jim's here, so I'm trying to remember her name. Melissa Ballard was at the workshop yesterday, and anyway, so her husband is able to buy really cheap or poor quality hay, but really cheap, like really cheap. and they bale graze it. So he readily admits, he says, I know I'm going to get maybe 50% utilization, but the hay is cheap enough where he wants cattle to be able to pick through there, get what they want. And believe me, he's putting it down in some really poor fertility situations on rental farms, so his hay waste is effectively becoming fertilizer also. So there's a trade-off there. It will. I mean, but 3 years from now, that will be broken down. That in the same area that was a absolute mat in the first and second year, 3 or 4 years will be the best pasture or the best forage in your pasture on a rundown farm. And then not using rings, like on that farm. Now that 85 cow farm was using hay rings, but that was 8 hay rings that they had to have there versus if they didn't. So there's a trade-off, and you've got to make that trade-off. I'm not saying one's right or wrong.
I think we'll move on with Jim's last presentation. Greg, will you be here a minute at the end?
I'll be here, yes, for sure.
So as we're